Okay, chapter 3.3, proportions. A proportion is an equation stating that two ratios are equivalent. So an equation always has an equal sign. That's what equation means. And proportion could be like two fractions that are equivalent. And you don't read it 2/3. Well, sometimes you can get away with that. But technically, you read this one, 2 is to 3 as 4 is to 6. So 2 is to 3 as 4 is to 6. So 2 is a little bit smaller than 3 in the same way. That's supposed to be an as 4 is a little smaller than 6. In fact, in exactly the same way. And we notice that there's some things we can do, like we can do cross products. Cross products are really cool. You multiply diagonally across the two proportions to find out if they are proportional. And if they are, the cross products should be equal. Cross products, or product is a multiplication problem. Okay, so cross products is like 2 times 6 should be equal to 3 times 4. And we can see that they are, because they are each equal to 12. So if we have something, we can usually use cross products to test to see if they are in fact proportional. And they should be. That's one quick thing that we should be doing. Let's look at something else. So if we say 4 is to 10 as 10 is to 25, then we should be able to do a cross products with 4 times 25, which is 100, and it should be equal to 10 times 10. 4 times 25 is 100, and 10 times 10 is also 100, so yes, they are proportional. They form a proportion. They are equivalent. Okay, so another way to do that, I guess the book is, I just glanced over there and it says that we should, this is the one that we just did, 4 tenths, 4 is to 10 as 10 is to 25. We could first simplify, because that makes our lives a little easier. 4 tenths is the same as 2 fifths, and 10 25ths, so we divide it here by 2. Over here we can divide both 10 and 25 by 5. 10 divided by 5 is 2, and 25 divided by 5 is fifths. So we can also say that, well, it doesn't equal yes. Yes, they are proportional, because when you simplify them, they are exactly the same. So we can use cross products, or we can just simplify to find out if they are in fact equal to each other. They may not look equal, and in fact they might be. What about 6 fourths and 8 twelfths? Now we can see right away that this is not going to be proportional, because 6 fourths is more than 1, and 8 twelfths is less than 1. So something more than 1 is not going to be equal. You can put a line through your equal sign like that to show that it is not equal. Okay, so they do not form a proportion. If we simplify this, this would be 3 halves. And this would be, let's see, divide by 4, we'd get 2 thirds. And 3 halves is not the same as 2 thirds. So no, they are not equal. Okay, or they're not proportional either. So you just have to kind of go through that, and you got to check for cross products to find out if they work. Sometimes it may give you, nope, not yet. Good. It doesn't try to do algebra on you yet, but you will get there. There's a story problems. You swim your first 4 laps in 2.4 minutes. So you swim 4 laps in 2.4 minutes. I noticed the book did it with 2.4 minutes on top and 4 laps on the bottom, but we're going to go ahead and we'll try it both ways and see what happens, see if it's the same, see if it matters. You complete 16 laps in 12 minutes, so should 16 laps be the same 12 minutes. Okay. Make sure we make sense out of that. We got 2.4 minutes and 12 minutes. Okay, so we can see here that they're at least potentially the same. I know that 4 times 3 is 16. 4 times 4, excuse me. 4 times 4 is 16, and so I should be able to multiply 2.4 times 4, and if it comes out to be 12, I should be right. That's one way to do it. I could also simplify down to the ones place. I could imagine that this is 24. That's kind of the crazy thing about this, is once you start working with fractions, there's all kinds of things you can do. 4 times 4 is 16. And 2.4 times 4 looks like it's not going to come out to be a whole number, 9.6. So 2.4 times 4 is 9.6. So this looks like no, if we did it that way. What if we just use a simplification process? 16/12 is the same as 8/6, just cutting in half, which is the same as 4/3. Okay, and what about 4/24? 4 over 2.4, that's a little bit like 24. And we could divide by, let's see, we're not going to be able to simplify that down to 3. We'd have to actually go up. Well, this actually tells us right here, look at this, 4/3. Could that be equal to 4 over 2.4? That cannot be equal, because the numerator is the same, but the denominator is different, and those two fractions are never going to be equal when they look like that. Okay. That kind of sets us up for it. We could also use cross products. What if we use it their way? 2.4 minutes over 4 laps is the same as 12 minutes over 16 laps. And it's the same thing, but we just multiply on the bottom. Times 4 to get 16, and 2.4 times 4. Oh, I'm writing another x, not a 4. Let me do a better job. Times 4. We know that's not 12, it's 9.6. We already did that work. So it doesn't matter if you set it up with the laps on top and the minutes on the bottom, or the minutes on top and the laps on bottom, the way they did it in the book. What does matter is that if you have a numerator, that you're using a consistent numerator. You wouldn't want to do 4, let me change colors just so we can see it. You wouldn't want to do 4 laps, well, that's not really a different color, 2.4 minutes. And it wouldn't work very well if you put the minutes on top and the 16 laps on the bottom. You kind of need to keep your numerators and your denominators or your ratios set up in the same way. They have to be uniform. Laps on top, minutes on the bottom, or minutes on top and laps on the bottom. Okay, that should be the end of this video.